Revolutionary robotic grip tech, safely handling slippery, delicate objects. Imagine a world where robots don't just grasp objects by brute force, but actually feel and predict when something might slip, adjusting their hold just like we do. This breakthrough could completely transform how machines interact with delicate or slippery items. And it's closer than you think. But here's where it gets controversial. Can a robot ever truly replicate the subtle, intuitive touch humans develop over a lifetime? And this is the part most people miss. It's not just about stronger grips, but smarter, more sensitive control. A team of researchers from the University of Surrey has pioneered an ingenious, nature-inspired technique that enables robots to foresee when an object might slide out of their grasp and fine-tune their movements to prevent that from happening. This innovation promises safer, more dependable robotic handling, especially for fragile, wet, or oddly shaped objects that traditional robots struggle with. Historically, robotic systems have tackled the challenge of holding things by simply squeezing harder. While this brute force approach works for durable items, it often backfires when applied to delicate objects, risking damage or failure. The new technology flips this notion by teaching robots to respond more like humans do. Instead of tightening the grip blindly, the robot senses subtle shifts that signal slipping and reacts by adjusting its hold or motion, sometimes slowing down or repositioning rather than just applying more pressure. This human-like finesse is a game changer. At the core of this advancement lies a sophisticated predictive control system powered by what the researchers call a tactile forward model. Think of it as the robot's internal intuition. It constantly monitors the object's movement and forecasts potential slip events before they actually occur. Remarkably, this system doesn't depend on extensive prior training with every possible object. Instead, it adapts on the fly, handling unknown shapes and surfaces with ease, which makes it incredibly versatile for the complex demands of real-world tasks. Published in the prestigious journal Nature Machine Intelligence, the study demonstrates that robots equipped with this method maintain far more stable grips, even in unpredictable, chaotic environments where conditions constantly change. This means robots are no longer limited to rigid factory lines, but can operate more flexibly and securely in dynamic settings. The implications are vast. In healthcare, precision robots might handle fragile surgical instruments without risk. In manufacturing, they could assemble complicated devices with delicate parts. In logistics, machines might efficiently sort packages of varying sizes and textures without dropping or damaging them. The possibilities suggest a future where robots move beyond repetitive, simple actions toward genuinely dexterous and adaptable helpers in everyday life. But let's pause and consider. Does this advancement mean robots will someday match or surpass human touch sensitivity? Or will there always be a nuanced gap between mechanical replication and human experience? The Surrey team's approach undeniably narrows that gap, but it also sparks debate about the limits of artificial dexterity. In conclusion, by mimicking the way humans instinctively adjust their grip to prevent slipping, this technology opens exciting pathways for smarter, more agile robots capable of handling intricate tasks with heightened safety and accuracy. What do you think? Are we on track to build machines with true human-like touch, or is this just another step in a long journey? Share your thoughts and join the conversation. Revolutionary robot skin beats human reflexes. E-Textile touch sensor transforms robotic grip. A groundbreaking invention in the world of robotics is set to revolutionize the way machines interact with their environment, boasting a robot skin that outperforms human reflexes and enhances gripping capabilities. This innovative fabric-based sensor could potentially transform the realms of robotic surgery, prosthetics, and industrial grippers, promising a new era of dexterity and precision. Picture this: robotic fingers reacting in real time, adjusting their grip based on the touch sensitivity of an electronic textile, E-Textile. This marvel mimics human skin's ability to sense pressure, slippage, and movement, allowing robots to perform tasks with unparalleled finesse. And this is just the beginning. But here's where it gets controversial: the speed at which this system operates. Faster than human response times. The textile sensor harnesses the tribovoltaic effect to generate electricity through friction, resulting in reaction times as quick as 0.76 milliseconds, peaking at 38 milliseconds. Human touch receptors pale in comparison, typically responding within 1 to 50 milliseconds. Imagine the implications for robotic surgery, where such precision could mean the difference between life and death. And this is the part most people miss: the sensor's adaptability to various robotic platforms. From advanced prosthetics to precision robotic tools for surgery, the possibilities are endless. The researchers behind this innovation are already planning to integrate reinforcement learning to refine control algorithms, pushing the boundaries of what we consider possible. So, let's ponder for a moment. Could this breakthrough in robotic touch sensors redefine our relationship with machines? Will it blur the lines between human and machine capabilities? We invite you to share your thoughts in the comments below. Is this the dawn of a new age where robots can truly feel? The study, led by Jun Liu, assistant professor at the University of Buffalo, and his team, including PhD candidate Vashin Gautam and associate professor Ehsan Esfahani, was funded by the University of Buffalo's Center of Excellence in Materials Informatics. Their findings were published in the prestigious journal Nature Communications. Revolutionizing robotics, fabric sensors mimic human skin. Imagine a world where robots can feel and manipulate objects with the same finesse as humans. This might sound like science fiction, but groundbreaking research is bringing us closer to that reality. Scientists at the University at Buffalo have developed a new electronic textile, E-Textile, that mimics the human sense of touch, addressing a significant limitation in robotic capabilities. But here's where it gets controversial. Could this technology not only enhance robots but also revolutionize prosthetics and human-machine collaboration? Robots are incredibly adept at many tasks, from assembly lines to space exploration. However, their ability to handle delicate objects with precision is often lacking. Whether it's dropping items or crushing them with excessive force, these basic human skills remain challenging for most robots. Over the years, researchers have equipped robots with cameras and other sensors to improve their object recognition and manipulation. Yet, a simple and cost-effective solution that replicates the human sense of touch has been elusive. Enter the E-Textile, a revolutionary technology described in a study published in Nature Communications on July 30th. This innovative fabric, developed by a team led by Jun Liu, PhD, an assistant professor in the UB Department of Mechanical and Aerospace Engineering, mimics the way human nerves detect pressure and slipping when grasping objects. The potential applications are vast and exciting. Liu envisions this technology being used in manufacturing, where robots and humans work together, as well as in robotic surgery and prosthetic limbs. The E-Textile's capabilities are remarkable. It's flexible, highly sensitive, and can detect not just pressure, but also subtle slips and movements. Vashin Gautam, a PhD candidate in Liu's research group and the study's first author, explains, it's like giving machines a real sense of touch and grip, which could transform how robots, prosthetics, and human-machine interaction systems interact with the world around them. To demonstrate its effectiveness, researchers integrated the sensing system into a pair of 3D printed robotic fingers attached to a compliant robotic gripper. When the researchers attempted to pull a copper weight from the fingers, the gripper immediately tightened its grip in response to the detected slippage. This dynamic adjustment is made possible by the tribovoltaic effect, where the slight movement of the object generates direct current DC electricity. The response time of the sensing system is impressive, ranging from 0.76 milliseconds to 38 milliseconds, depending on the experiment. This speed is comparable to human touch receptors, which typically react between 1 and 50 milliseconds. Ihsan Isfahani, PhD, an associate professor in the UB Department of Mechanical and Aerospace Engineering, notes, "This sensor is the missing component that brings robotic hands one step closer to functioning like a human hand." The research team is already planning further testing, including the integration of reinforcement learning, a form of artificial intelligence, to enhance the robot's dexterity. This could lead to even more advanced robotic systems capable of performing complex tasks with precision and care. And this is the part most people miss, the potential impact on prosthetic limbs. By incorporating this technology, prosthetics could provide users with a more natural and intuitive sense of touch, significantly improving their quality of life. As we continue to explore the possibilities, one thing is clear. This breakthrough in touch-sensitive technology is poised to reshape the future of robotics and human-machine interaction. What do you think? Could this technology truly bridge the gap between human and machine? Share your thoughts in the comments below.